Welcome to BKSS Academy. Now we are discussing about queue in data structure using C. It allows insertion at one end and removal of the elements at other end. This is the main rule of the queue. A queue can be defined as an ordered list which enables insertion operation to be performed at the end, which is called as rear, and delete to be performed at the end, at other end, which is called as front. So rear and front are the two pointers used for the operation of the queue. So it can also called as, it is the linear data structure which allows insertion into the queue in rear end and deletion or removal of the element from the queue at the front end. It follows the principle of FIFO, first in first out and last in last out. Its example is printer. When a printer is connected to a network, so every system, if accessing to the element to the printer for printing purpose, so it will maintain a queue. Similarly, online ticketing in the counter, that may be film hall or train ticket. So this is one example. This is the queue where this one is front and this one is rear. On this side elements will be inserted and on this side elements will be removed. For inserting the element into the queue, that operation is called as enqueue, and for removing the element from the front side, it is called as dequeue. Application of the queue is CPU scheduling, handling interrupts, and call center phone calls. CPU scheduling in operating system and handling interrupts in computer architecture, and call center phone calls. When multiple people are calling to the call center, if every executive is busy on the solving the problems of the client, then the waiting persons will be maintained in a queue. Its operations in queue is, that is enqueue, dequeue, is empty, is full, and peak. This peak is of two type, that is front peak and rear peak. Enqueue add elements to the end of the queue. Dequeue remove the elements, that is rear. Enqueue operation adds element. Enqueue operation adds element to one end of the queue, that is rear end. Dequeue remove the element from the front end of the queue. Is empty, check the queue whether it is empty or not. Is full, check the queue whether it is full or not. Peak, get the value of the front of the queue without removing. Similarly, working purposes, that is two pointers used, that is front pointer and rear pointer. Front track the first element, rear track the last element of the queue. Initially, front and rear, initialize front and rear to -1. It is the first situation of the queue. Enqueue is full queue. If queue is full, set front 0 and increase rear by 1. Add new element in the position rear is pointing to. Similarly, dequeue is having this kind of algorithm, and time complexity for enqueue and dequeue is big O of 1. Thank you.